Hi guys, my name is Allison. I am the 61 BTA in charge of homework, and so I'm going to be doing some introduction videos throughout the semester to help you sort of get started with the homework. And so today's video, we're sort of just going to brush over what the homework is about, why we're doing it, and then I'll actually be going over the solutions because this homework assignment is ungraded. And so I'll be able to just show you sort of how I would solve these problems in case you're stuck. But I would recommend trying the problems before watching the solution portion of the video. But with that being said, homework 0 is about being a good classmate, and then also Java 101. So the grade scope assignment covers how to communicate respectfully with your classmates, and it is worth 2 points. That's the entire homework, and it is not optional. It cannot be dropped. And so unlike other homeworks, which you're eligible to drop your lowest score, homework 0, you are not allowed to drop just because the professor and the staff agrees that communicating respectfully is not optional. You can't drop that. So this part is mandatory. And then we have the coding assignment portion of homework 0. And so this is ungraded. It's worth 0 points. And there is no auto grader. It's really just meant to introduce Java syntax. And even though it's technically optional, I strongly recommend it if you've never coded in Java before. And I assume a lot of you haven't. Personally, I'd never before taking this class. And so homework 0 is very, very helpful for that. So why do we need homework 0? Specifically, the grade scope portion on being respectful, right? Well, 61B is about teaching you to be a software engineer, and real software engineers have to work with other people. You're constantly, communicating with your teammates, with your managers, whoever. And so it's really important that you are able to communicate yourself in a way that doesn't hurt anybody's feelings and you don't offend anyone, because it's, it sucks, to be on the receiving end of that as well. And every semester we have some students who feel that they have been excluded or disrespected by their classmates. And that's really not what we want. We want to create a welcoming environment where everyone feels comfortable. And this is particularly hard for underrepresented students or minority students in computer science. They're oftentimes even more, the target of discrimination. So we think it's really important that we sort of put a stop on this behavior and sort of set a precedent early on. And so homework 0 objectives. The first thing is teaching students how to communicate respectfully, right? The second thing is setting a precedent for what kind of behavior is not okay. So that later down the line, if someone, says something really cruel to you, we can point to this homework and say, hey, we told you from the start that this kind of behavior was not allowed, and sort of work from there. And the last thing is that with homework 0, we're also hoping to help students sort of feel cared for and seen, just to know that we take this very seriously. We're putting an assignment out there about it, and we want everyone to feel comfortable. I want to make a note that I know everyone has different experience levels with this sort of topic. For some people, they might feel like, oh, this is so elementary, like this is so basic. Of course, I know how to talk to people and, like what kind of things are inappropriate. And if you feel that way, I hope you understand and can appreciate we're just trying to create a baseline level of understanding for everyone. On the other hand, some people may feel like, oh, I've never seen this kind of stuff before. I feel totally lost, or I don't even know what all of these vocab terms mean. And so if that is the case, I recommend reading some more resources, which are included at the bottom of the spec for whatever topics you're confused about. And it's okay if you are confused or still learning. All of us are still learning, right? And so that's the point of this assignment, is to help you feel less confused. And with that, we can sort of now talk about the coding exercises. And so I'm going to go over, number 1, how to run your code. And number 2, what you're probably all here for, a solution walkthrough. So I'm going to sort of show you my setup. So what I have here is I have my project just open in my text editor of choice. I'm using Atom. You can use whatever you want, whatever you're already comfortable with. Later in the class, we're actually going to switch to all using the same like text editor, or it's actually an IDE, IntelliJ. But for now, we're not going to deal with that setup thing yet. So let's just open it whatever you like. And so I opened the homework 0 folder here, and you can see that I have the skeleton. And so right now, the only method signature included is isEven, and it just returns false. So we're going to have to fix that up. We also see we have tester.java, and we've actually uncommented or commented out all of the other tests because they reference the methods we haven't written yet. And so we just wanted to be able to compile. So we've just commented them out. Otherwise, the reference to solutions.max would be an error because we haven't written max yet, right? And so off the get-go, I just want to show you what happens if we run this right now. So you can see that in my terminal, I'm in my homework 0 directory, which is what I have open here. And if I list the files, I'll see I have solutions.java and tester.java. And so I also have these class files, and that's what's made when you compile your code. And so if I do java c tester.java and solutions.java, we'll see my code compiles. And so you can imagine if I had made changes, every time you need to recompile, right? If I update my solutions code, I should recompile using java c. Now that I've compiled both of them together, I can run the tester class, and so I'll do java tester. And so it says all failures shown below. If none, congrats, you're good. But clearly we are failing the isEven test because there are 2 cases where it expected true and received false, right? And so we can go check that out a little bit, right? And so we're going to see, oh, 2 of these assertions must have failed, right? And so now it's time to actually write the method so it works. And so I'm going to go ahead and start writing this isEven method for you. And so I guess the first question is, how do we want to approach this, right? Well, there's a hint in the spec that says to use modulo. If you're not familiar, modulo is kind of like just taking the remainder from division, right? And so for example, 5 mod 3 is like saying divide 5 by 3, and the remainder or the leftover is 2 there, right? And so in this case, 5 mod 3 would give you 2 because that's the remainder when you try to divide 5 by 3, right? Similarly, if I were to do 7 mod 4, I would also get, or 7 mod 4, I would get 3, right? Because 7 divided by 4 leaves a remainder of 3. And if I were to do 11 mod 3, right? 11 divided by 3, 3 could go into it 3 times to get 9, and then you'd have 2 left over. So the remainder is 2. So 11 mod 3 is 2. Sorry if me saying that out loud wasn't very helpful, but that's basically how modulo works. If you're confused, I would maybe watch like a math tutorial. But just sort of thinking out loud, if something is even, that means it's divisible by 2, right? Or in other words, that number modulo 2 would always be 0, right? Because there's no remainder when you divide by 2. It's evenly divisible by 2. And so we could do something like this, for example. If x mod 2 equals 0, or it's cleanly divisible by 2, return true, else return false. And this works, right? If I add the semicolon, it works. But you might be noticing this seems like a lot of code, or like a couple lines of code, and maybe we could simplify this, right? Because this statement essentially will evaluate to either true or false. It's going to evaluate to a Boolean. And so we're saying if this is true, return true. If it's false, return false. And so you're wondering, what if I just return the value of this statement, right? Because if it's true, then I'll have returned true. And if it's false, I'll have returned false. And so we can actually simplify this all down to return x mod 2 equals 0. And so this will evaluate to true if we're divisible by 2 or if we're even, and it'll return false if we're not divisible by 2, or in other words, we're an odd number, right? And so now I can try to rerun my test. And what's going to happen if I just do Java tester? Oh no, I'm still failing 2 of my tests, right? However, it's because I needed to recompile. And so I'll recompile like this. Okay, all failures shown below. If none, congrats, you're good. And so that's really awesome. That means that we have correctly done isEven, or at least correctly enough according to these tests. I'll assure you they are correct. So that's pretty cool. In cases where it should have been even, right? Like 2 and 10, we got true, or we asserted true. And in cases where it should have been odd or like not isEven, we correctly got false. So now I'm going to actually write in the method signatures for all the other methods and uncomment the other tests just so we can sort of see what happens. And so we are filling out, there is max first, right? And so that is going to return an integer. And it takes in an integer array. And for now, we'll just return 0 because we're not filling it out yet. We also have wordBank, which returns whether a string word is in the given string array bank, right? And we'll return false by default just because we haven't done it yet. We have to put something in there as a placeholder. And finally, we have threesome, which I believe is also Boolean. And so this one takes in an integer array. And we'll return false here as well. Cool, so I've written on all those signatures. You're gonna notice I followed the standard format, right? Where I first say whether it's public or private, you can worry about that later. I include the static keyword here. Again, don't worry about it. You'll learn more about this later. And then I do the return type, the name of the method, the name of the arguments, and the type of that argument, right? And so in the example of wordBank, it takes in 2 different arguments separated by commas, and word and bank are the names of those arguments, and the types are string and string array, respectively. Now that I've sort of written those, I can uncomment these lines and also uncomment these so that they'll be run. And so what's going to happen if I recompile? Oops. Okay, it says there's an error here. There's an identifier expected in the signature for threesome. And that's correct. I forgot to name or identify the argument, right? We know the type, but what's it called? And so I will call it A. Now, let's try again. Cool, and so we're failing everything, but that's what we expect, right? We literally didn't write the solution, so it'd be quite alarming if we were already passing. So let's go ahead and fix up these. I'll start with max first. So the max method takes in an integer array, and we want to return the biggest number in it. This implies that we need to go through the array one by one and look at all the elements and keep track of the biggest thing we've seen so far, and then return the biggest thing. So I'll start with just that whole, how do we look through all the elements? Well, one way we can do this is a for loop. And so we can say for int I equals 0. So when the for loop starts, we're going to create a new variable named I and initialize it to a value of 0, right? And then we'll keep looping until I is, we'll loop as long as I is less than a.length. And then we're going to increment I at the end of every loop. And so we can do that using I plus equals 1. You could also do I plus plus, but some people feel like that doesn't belong in Java. I don't know. We can do either way. And so this is a for loop in Java. So again, this only happens at the very start of the loop. We check this every single time to decide if we should enter the body of the for loop again. And we have to do this at the end of every loop. And so basically this loop will happen as many times as a.length because we're going to start at 0 and go until a.length. Now we can see we've had this loop structure set up. And so the question is, how do we keep track of the max? Well, I'm going to create an integer called, let's say, max so far, right? And we will just initialize it to be the first thing in the array, right? Now I'm going to say, if the current element is greater than the max so far, we should update the max so far, right? So if a of I, which is the current element, right? We're assuming I is our index that we're incrementing and looping over. If a of I is greater than max so far, so if we're bigger than the max, we're the new max, right? So max so far should now be a of I. And so this should theoretically work. And the last thing to do is at the end of the loop, we've looked over every single thing and we can return the max so far. And so some of you might be wondering, why did I initialize max so far to a of 0? Why don't I just make max so far -1, right? And then that way we can loop through everything and it'll always get updated. But what if the int array was full of negative numbers, right? What if the int array only contained let's say -5, -3, -2? Well, then max so far is going to be greater than those, right? And so we would actually end up returning -1, which is not the correct max of this int array. And so we just want to actually set it to a value in the array for sure, so we can guarantee we're not making any silly mistakes like that, right? And because we're actually already setting it to be the 0th element, technically we can start this for loop here at 1. And so this works. And this is our solution for max. Let's see if it works now, right? We don't know for sure until we run the tests. Cool. And I see no failures for max test. So I think we're good. Of course, do we know that the max tests are super thorough? Maybe not, right? We don't have an example with all negative numbers. And so if you wanted to, you could just add another test right here, right? And so we could say, what if we had all negative numbers? We want the max of this list is -1, right? So in other words, we should assert it's equal to -1. So let's try adding that. And let's see if we still pass. And we do. No failures for max test. So far, so good. So I believe that means we're done with max. And now we can move on to wordbank. Take a breath. If you haven't already, you can pause the video, think about the max solution, and make sure it makes sense to you. And now we're going back into wordbank. And so wordbank is a method that basically takes an array of strings and then a particular string and says, is this word in the word bank, right? And so we can look at our test for some examples. And so here, if we have a string array with big, cool, and fast, and then we say, oh, is big in the word bank, right, that we defined here, that should return true, right? However, if we look for dog in this list or this word bank, that should be false because it's not in there. And so this method is going to be pretty similar to max. If you haven't already, try it on your own. And we will now go ahead and do it. So this one, we're going to go with a similar looping structure, right? You could do for int I equals 0, I less than bank dot length, I plus equals 1. And then you can say, so now we need to check basically, is this word in the bank? Or in other words, are any of the elements in our bank equal to this? And so the correct way to do this is to say bank of I dot equals word, right? We're not going to do bank of I equal, where'd that go? Equals word, because that's actually only going to return true if the two strings are the exact same string in memory, or in other words, they're living at the same memory address. But if that was the case, good, autofill, something like string A equals high and string B equals high would not be guaranteed to return the same thing because A and B could be at different memory addresses, or they will be. Strings do behave a little weirdly, but in general, we always compare strings with dot equals. And so we've done bank of I dot equals word, right? So we're saying the string that is the ith or current element of bank, if it's equal to the word, then we know the word is in the word bank, right? So if bank of I equals word, then our word is in our word bank and we can return true. Notice that if we return, we're going to exit the function immediately, but that's fine. Once we found the word, we're done. We say, oh, we found it, we're done, let's go. What happens if I reach the end of the for loop and I hadn't already exited or returned true? Well, that would mean I looked through every single item in bank, tried to see if it was equal to the word I'm looking for, and it wasn't. In other words, word is not in the bank. So if I reach the end of the for loop and I haven't already returned, it must not be in the bank. And so I'm going to return false. And now let's see if this is a working solution for wordbank. So I recompile because I've updated my code and I run Java tester and I see that I'm no longer failing the wordbank test. So that's really awesome. We finished wordbank. So again, you can take a deep breath, think about that solution, why it makes sense. And finally, we can move on to threesome. And so this method basically says, are there 3 elements in A that add up to 0? This one, again, we're going to need to do some more loops. And so the idea is we just want to take 3 different elements and sort of see if they are, when you add them up, they're 0. And the simplest way to do this, right, would just be to try all possible combinations of 3 different elements. And so the way we can do this is to do 3 nested for loops. And so a nested loop just means it's a loop inside of a loop, right? And so we can say for int I equals 0, I less than a dot length, I plus equals 1, right? And so this is going to sort of be the outermost loop. And then we'll do an inside one, and we're going to give it a different name, right? Because we already used up I. So this time we'll use j. J less than a dot length, j plus equals 1. And then we'll do k. I, j, k. I just kidding. Okay. So we have these nested for loops, and our goal, as we said, was to look over all possible combinations of different, like 3 different elements in A and see if they add up to 0, right? And so we can imagine that I, j, and k are sort of different indices, and we're going to see if a of I plus a of j plus a of k equals 0, return true, right? If we found 3 such indices in A, or 3 such indices I, j, and k that are valid indices within A, right, from 0 to a dot length, and the items at those indices add up to 0, return true. This is really awesome, because basically we're done with this method, right? The only thing left is, when do we know we haven't done it? When can we return false? Well, sort of similar to wordBank, if we reach the end of our loops and we're all done, we've checked all possible combinations and none of them resulted in us leaving the method or returning true, then it must not be possible. And so we'll return false. And so again, this just tries all possible combinations of different items in A and sees if they add up to 0 and returns true if they do. So now let's see if this works. Yay, no failures. And so this is all of homework 0. Hopefully it was helpful for learning some of that Java syntax. I want to note that we actually ended up using for loops for everything here instead of while loops, right? But technically we could convert some of these to while loops if you're curious. I just think that they're a little cleaner as for loops, but we could try doing max with a while loop too, right? Let's try just redefining it and doing with the while loop really quick, just to show you for your reference. And so we'll do sort of the same int max so far thing, right? But we could say int I equals 0, and while I less than a dot length, and then we'll do the same thing as before. And at the end of every while loop, we'll increment I, right? Or sorry, I plus equals 1. Like, it's a bad habit, guys. There's nothing wrong with it. Some people, I think it might like not go with style guides. I don't know. And so this does the exact same thing as max, the regular max with the for loop, but here we've just converted it to using a while loop. And so we start the max so far as the first element, and we set our sort of indexing or counter variable to 0. And then we say, well, our index is less than the size of the array. We're going to check to see if that element in the array is greater than our max so far. We'll update if necessary, and then we'll increment our index. And now if we've incremented, but we're still within the valid range, we'll keep going. And so we do this loop over and over and over, incrementing every time, and eventually we'll increment to where we're at the edge, or we've reached a dot length, and then we've reached the end of the array, and so we can return the max that we found. So this is just an example of how you can use a while loop. There will be cases where using a while loop is cleaner and better, but in this particular homework, it just happened that I think for loops look a little nicer and cleaner, but there will definitely be cases where a while loop makes more sense. So yeah, I hope that this was helpful to you. If you have any more questions, feel free to post on Piazza. Don't comment on, or you can comment on this YouTube video, but I won't answer it. I'm not going to notice. If you have questions, you should post them on Piazza. But yeah, have a great day and enjoy everything. Enjoy the weather. Enjoy spring break. I don't know why I said that. It's January. I'm already thinking about it.